Hi everybody and welcome back to my lab. Today I have for you a review on the Baku. It's the 85AA hot air gun. It's used for soldering and desoldering as well as anything else that you need hot air for. And the reason I want to review this is I've been using it for quite some time and I'm happy with it, but it does have a major flaw, and so this is I want to let you know what the issue is, how I plan to fix it, and then in a subsequent video we'll tear it right down to make the modification. And also I want to use this video as a bit of a teaser for a couple projects that I'm working on, and I would love your comments down below to let me know if this is something you would be interested in. Kind of impromptu survey of some products that I would like to make for you guys. Okay. Okay, welcome back. So here you can see I have my Amazon page opened up, and I did purchase this way back in March 14th, and I've been extremely pleased with its function. Now I did allude that there is an issue with it, and we're going to get into that in a minute, but let me talk about Amazon and some of the pitfalls that you need to be careful with. Now, I bought this because it was $60 as opposed to much more. If you check out some of them, they're into the hundreds of dollars. And at the end of the day, the function is similar, if not the same. There is actually, if you search for the 858, you will find a bunch of units that look identical to this. They just, maybe the branding here varies a little bit. And so be careful not to pay too much for the exact same thing. On the other hand, some units will look the same, but their function is absolutely different. There are, for example, clones of programmers that look identical to the OEM, but when you dig into it a little bit, you find out that no, indeed, they are clones. And yes, they may work, but you won't know until you maybe spend 30 or 40 or hundreds of dollars and bring it home, and it may not work. So caution there. Now, using this hot air gun, I'm going to link in a video. You can see where I actually take an SMT part and solder it. This is something that you do more and more as you start working with surface mount components. One of the things that you want to watch for and make sure that you get when you purchase one of these is different nozzle tips. The small nozzle tip is great because you can get in and do some fine work, and to that you need to make sure that you have proper fan control. So you want to be able to slow the air down so you can get in on the small components, but not have the air velocity so high that you blow it away. You also want to be able to put larger tips on so that you can heat up larger components. And again, you're going to need more airflow for that, as may be. It's also great that for taking things like screen covers off, where you need to gently warm it, but maybe a little bit more than a hair dryer. And so in this case, you would actually take off the nozzles altogether and turn the temperature down, turn the fan up, and then slowly warm the screen up so that you can get your spudger underneath it, or the same with your battery. So these are very, very handy tools when you start doing any repair work or any mod work. All right, so let's go over to the bench. We're going to take a look at the unit. I'll actually turn it on. We'll melt some solder, and then I'll tear it down and describe what I'm going to do with it. And yeah, all right. Here we are. We're looking at my Baku 858A on my bench, and you can see that it's not overly big. It does fit nicely along with my soldering iron and what have you. It's quite convenient for me, especially doing solder mount components. When you're laying out your bench, though, make sure that you keep a couple things in mind. One is that you need to give some space behind it, because it has a cool down period. So once you turn it
off or put the handle back, it wants to run for a little while to cool down the heater. And so you don't want it too awfully close to a wall or a flammable surface because, well, you'll either scorch or start a small fire, which would be bad. And yeah, the other thing is that I run this one on a dedicated plug, as well as my soldering iron on a dedicated plug, so that their loads don't trip any breakers. Now, being 700 watts and my soldering iron being less than that as well, we could probably get away with it. But when we start pulling heavy loads from the power supplies, it's very important to have clean power, especially if it has something like PWM on the outputs for some triacs, where we would start to see some noise coming back to our signals. So here we are. We're going to fire this up. So a couple things to keep in mind is, one, you don't want to do any of this directly onto your mat unless you have a high temperature silicone mat, and the reason is that you will actually damage your mat because the temperatures do get quite high. And so what I've done is I've lifted this up, and we're going to look at just removing this little switch. Now, the switch isn't worth much. I wouldn't normally try to recover something like that, but they are extremely hard to desolder because there are 4 pins. They're spaced very far apart, and you'll not likely be able to heat up all 4 pins conventionally. But here we are. I've got the small tip on it. I don't want to melt the plastic nib here on the contactor. So yeah, and it's going to be loud. I'll apologize ahead of time. But let's start with 325, and we'll set the speed about halfway, and I'll turn it on. So here we are. So this guy here. Okay. And if we watch the LEDs, I'm going to see the top one turn off, and you can see that it is pulsing. And so this is what I was talking about. We want to be careful with our power supply not being like our power source, that this could, if it's not filtered properly, send noise back onto our AC lines. And we're going to take a look inside the unit here in a minute when I tear it down. So yes, this one sets temperature. I can turn it up, and you can see it turns it on, and the fan is controlled by the lower. So let's get in, and we're going to heat this up a little bit. And we want to keep moving. One thing we don't want to do is to overheat any of the pads. We don't want to lift them. And we want to be careful. This it's going to be hard for you to see, but there's a little R27 down here, a little 0805 pull-up resistor. We want to be careful. We don't want to remove it as well. And so I'm going to direct the air away from that component the best I can, and continue to heat things up. Ideally, I would be doing this on a chip where the pins are very close, like U10 here, and that has its own benefits. You don't have these long distances between pins, but obviously more of them. And there we go, easy peasy. Right, so. Works very well. I have no complaints about its function. Where my complaint comes in has to do with the Hall effect switch in the handle. So you'll notice when I set this in here, no matter what I have the temperature set to, it's turned off, right? It's trying to cool down. But if I rotate it to just the wrong place, it could, there you go, turn on.
And this is a major flaw in the design, in my opinion. And the reason why I say that is if we leave it here to cool down and reach its minimum temperature, both LEDs go off. Now the 858D doesn't have this problem. The reason why it wouldn't have this problem is because it has an LCD, or pardon me, an LED display. The added expense, however, of the display doesn't warrant, in my opinion, the feature. What I'm trying to say is, I don't see why I need to have a temperature indicator for something that is this crude. There's never a need for 351 versus 350 degrees. Even the calibration on here is somewhat useless, in my opinion. I mean, I've never calibrated this because I'm desoldering stuff. I'm not really that concerned. If I was doing low melt materials and trying to use it for a reflow oven, perhaps I would be more inclined. So here we are, what would appear to be a safe state, and unless you actually check the switch, the opportunity to have it bumped, have it moved, and turned back on is there. Okay, so what I want to do is I want to add an LED to this that is going to indicate the condition of the switch and whether or not the power is armed, so to speak. All right, so let me get this stuff out of the way here. Disconnect our power. I like Electro Boom, but I don't want to emulate him. All right, and let's take a look at how this is constructed, and we can put together a plan. Now, one of the things I do like about this, while I have the screwdriver out, is it can be set up for left or right orientation, and that's fantastic. That's a brilliant little bit of forethought. All right, well, it wasn't that easy. All right. Okay. Giving it a quick look here. Nothing too awfully surprising. A 3043, so there's our optical isolator. I'm seeing some transistors, LM 4324, so this will be for your temperature control. There's your trim pot here for your calibration. You've got fan control here. It's going to be a triac of some sort, I'm sure. Let's see. It's all low voltage, so it's coming off a transformer, so that's fantastic. That means that's a good thing. That means that we're not going to be seeing that noise going upstream. They're not actually switching directly. Wait, do I take that back? So we have power coming in on the blue wires, and looks like it's coupled to the yellow wires. I'm not going to take this all the way apart. I have no idea. Oh, jeez. Yeah, I'm not getting in there with my small screwdriver. It's definitely not worth it. A hassle to me. But the blue and the red, so we're definitely turning on and off the high voltage, the high current from the transformer. We definitely have high voltage coming over here somewhere. There's a tip 122, so that's a transistor. And so they are switching the DC somehow. Although that could also be part of a voltage regulator circuit. 5 4007s here. That's an odd number.
I really don't want to get into reverse engineering this whole thing. 2N290 2904. So yeah, that's just a transistor. Likely they have this is all part of a voltage regulator circuit. And yeah, they're going to have power going out. This is going to be for the switch, likely. Yeah, con 1, thanks. That's useful. My suspicion is that this is part of the switch, the Hall effect switch in the handle. Then we've got the connector for the temperature. We've got connections for the motor and for the heater. And as you can see, there can't be a whole lot of power going out there because of the size of the wires. I mean, these are pretty light little wires, so, and a major concern of mine if we were pushing much power at all. And this handle is used on a lot of these units, so I'm not too awfully concerned. Okay, so my plan is going to be to pick up some power here. You can see they didn't spend a whole lot of time fixing this up so that it's nice and clean. You've got kinked LED leads on here. So I'll do something similar. I'm going to probably be a little bit more fussy with mine, but I will drill a hole in here. I will mount an LED and run it back to a power source somewhere, so that when I turn this on, if it's armed, I'll get an LED indicator. So all in all, I'd call this a reasonable unit. It's definitely paid for itself. Their abundant use of hot glue is less impressive, but it is what it is. It's built to a cost, and I get that. The capacitors and the components, there's nothing to write home about. I mean, single-sided circuit board, that's it's all done as cost effectively as you could imagine. The fact that they do have some protection on, that's high voltage. All right, that's what that capacitor is all about, is they are trying to dampen the signal coming back. So that will be a TRIAC, a BTA12. I misread that the first time. 8008, so that'll be a date code. So we'll check into that. That's likely a TRIAC being driven off that opto, but I don't know, without getting into it, if it actually does any zero crossing. So we might see some noise coming back off that. And now I feel a little bit more comfortable, and not that I'm comfortable with the high voltage on these wires necessarily. We can check the rating on that, but that the current will be lower, so the wires aren't going to get quite as spicy. All right. Okay, teaser for future projects. One of the things that I've always struggled with was breadboarding, and particularly when I have components that I want to send away. I don't expect them back because they're going to a client. And one of the things that I need to do is to make a prototype, make something super quick that is going to get played around with and may or may not be destroyed in the process. And so breadboards don't really do the trick for me most of the time. So what I really am looking for is a board that will accept a chip, and I can solder to it or put in some connectors. That said, there are things out there that fit the bill, especially that you solder to. Omnilux makes some that will accommodate a microprocessor that would fit the bill. The issue is that they're quite expensive for some reason. They tend to also have a bunch of peripherals that you may or may not need, and there's some associated cost with that. And so
The project that I've been working on and plan on issuing very soon is a little bit more simple. So a switch between 3.3 or 5 volts that you can put in a range of voltage to, and has a couple peripherals available but aren't necessary. And then you can directly access all of the registers, which is something that some do and some don't. One of the things that I don't like with things like the Arduino is those analog pins are dedicated as analog pins and others aren't. But the microchip PIC series tend to be able to switch between analog and digital at will. It's all in the registers in the setup. And so that accommodates my style of programming and board design much better. So I'm planning on doing something along those lines for the 16 and 18F series, and probably up to a 28 pin device. So if this is something you're interested in, send me a comment, and we can chat about what you would like to see, and maybe we can make up some boards, and I'll let you know. The other project that I've been working on is a power supply. There are a plethora of power supplies out there that are for low power. And one of the things that seems to be missing, however, is a power supply that is able to do a plus and minus rail for op-amp education. And so one of the things that I'm planning on is a power supply that has a plus and minus rail, as well as a variable voltage that would run off USB. And under the current medical conditions, this may be ideal for students. So if this is something that you're interested in, again, please send me a message and let me know if you think this is something that would be useful to you, or if it's something that not really that useful. Perhaps people should bite the bullet and buy 2 or 3 power supplies, depending on how many outputs you have. All right. If you like this video, please give it a thumbs up. If you didn't, constructive criticism is always appreciated, and that thumbs down tells me just as much as a thumbs up. Comment away in the comments, and do check out some of my other videos. All right. Thanks, and have yourself a great day. Bye now.